In this video, we're going to use prices of zero coupon bonds to calculate spot rates. So notice we are given the terms of some zero coupon bonds and the price of a $1,000 zero coupon bond in each case. Now remember, the individual spot rates are the yield to maturity for a zero coupon bonds with that same term. So if I know that the price is $9.85 and I know it's supposed to mature at $1,000, then when I take the $9.85 and multiply it by the accumulation factor, the spot rate for 1 year, I have to get 1,000. So if I solve that equation, I can get what S1 is. Here, I know what the price is for a 2-year zero coupon bond that matures for 1,000. I know I need to use this 2-year spot rate, and this is the accumulation factor, and again I need to square it because I have it for 2 years. So this gives me the 2-year spot rate. And then we do the exact same computations for the 3-year spot rate and the 4-year spot rates. All right, so each of these now are going to help us to figure out the amount X at the beginning of each year that the investor needs to make in order to accumulate 20,000. All right, so the first one, the value of X, is going to be deposited at time 0 and accumulate to time 4. So that's like we have a zero coupon bond. You would buy a zero coupon bond at time 0 and let it mature to time 4. Okay, so that first payment is going to be subject to the 4-year spot rate. Notice then that, pardon me, if I want to do the accumulation factor, I would have 1,000 over 940 for that 1 plus S4 to the 4th. So if you rearrange some things, I could write that as 0.94 to the negative 1, which is going to make the slide look a little bit better on the next slide. This one would be 0.95 to the negative 3. This one would be 0.965 to the negative 2, and so on. All right, so anyway, this one that was made at time 0 is going to grow for 4 years, so we'll use the 4-year accumulation factor. The one that's at time 1 will grow for 3 years, so we'll use the 3-year accumulation factor. And so on. The one at time 2 will get the 2-year accumulation factor. The one at time 3 will get the 1-year accumulation factor. All right, so I'll multiply X times the 4-year accumulation factor, multiply X times the 3-year accumulation factor, and so on. Now again, like I mentioned, if I go back to the previous slide, notice that 1 plus S4 to the 4th is 1,000 over 940. Or that's 0.94 raised to the negative 1. Like I said, it's just a little bit nicer on the slide to write it that way. So we get 0.94 to the negative 1, plus 0.95 to the negative 1, plus 0.965 to the negative 1, and 0.985 to the negative 1. Solving for X, you get that yearly deposit that needs to be $4798.51.